to get a discussion kick-started.
Okay, so about 5 papers were presented in this session. The first presenter, Society of Mind, tried to define an architecture that helps agents communicate, cooperate and coordinate. So basically work based on the works of Marvin Minsky. If I remember correctly, he had given the notion of perceptrons when he wrote this book, Society of Mind. And perceptrons basically means an artificial neural network. And this work appears to be based on that notion. The second presenter spoke about holonic agents for design and manufacturing integration in virtual digital cells, wherein he introduced holonic as well as holonic fuzzy agents. I couldn't follow the work properly, therefore I won't be able to say much on this work, where exactly it led to. The third paper proposed a framework called Sesimas. If I remember, I was one of the reviewers of this paper, so I remember this one. Is basically talks about, takes inspiration from human immune system, wherein it tries to implement certain notions of, like, for instance, self-healing or self-regulation, and tries to imitate those kind of concepts to deal with how to manage critical information infrastructure in an organization through self-healing and self-regulation. But I was wondering that this concept, the managing the critical information infrastructure in an enterprise, why this framework cannot be extended to manage the entire enterprise IT, which includes event management, incident management, problem management, as well as change management. Because both are simultaneously existing, the critical information infrastructure as well as the enterprise IT as a whole. In some sense, it is a part of enterprise IT. So I was just wondering why this framework cannot be extended to cover the entire enterprise IT and not only confined to critical information structure management of the enterprise alone. The fourth paper, which is very familiar for me because it has been there in our organization, a project monitoring methodology for distributed product generation engineering. The challenges in this kind of work comes from the fact that the team is distributed across different time zones, synchronous as well as mostly asynchronous communication and synchronous communication as well. The different time zones also includes that the teams have different cultures. So organization may be based out of Germany, but the teams are, some of the teams are in Japan, and not every member in that team is a German. Because he could be of the local, coming from the local culture. So that all together brings up a huge challenge, how to manage such a distributed team, which is not only distributed in kind of locality, in the physicality, or the different time zones and a different culture as well. So how to collaborate? For instance, the tool came iCollab, which basically was how to really establish collaboration in such a distributed team. So that is the purpose of this one. And finally, we come to holonic superposition intelligence of multi-agent systems. This work appears to be very attractive in the sense that it is trying to exploit an existing quantum mechanical phenomenon, the superposition phenomenon, wherein a particle appears to be in multiple states at the same time. And as soon as an observer makes an observation, it collapses and assumes one particular state. Yesterday's talk I was mentioning that the difference between quantum mechanics and other physics lies in here itself. The other physics observer is not really part of what is being observed, while in quantum mechanics it does. And that I was trying to strike an analogy that even in systems engineering also, we must consider the observer, his knowledge, as part of the entire the system under consideration. The only problem that appears to be in here in this particular idea, not about the paper, idea is that the computer that we use is based on von Neumann architecture, which basically has 0 and 1. And it can be either in 0 or in 1. It cannot be in both. Now, how to implement such a thing on von Neumann architecture, which is basically quantum mechanical nature, and they are poles apart. So my feeling is that this kind of work will really will be able to express its full power when a quantum mechanical computer is actually constructed. Then an architecture is proposed which can have a multiple state, not only 0 and 1, and it may allow the function to be in any of the state simultaneously. So that is what basically, and this could be really interesting if it goes to that level. So overall, it has been a very interesting session. Some good ideas have been thrown up. So congratulations and all the best for all the authors.
Now, we've got 7 more minutes of discussion now. So, is there maybe any questions that anybody would like to ask any of the authors? Any more questions, or would like to ask or discuss or differ from Dr. Rao? I see some smiles, but I don't see some questions. Question? No remark?
I missed a lot of talks.
Oh, okay.
And you go back to read once the slides come out.
Well, is there anything else that anybody would like to add? Any, how can I say, very wise statement about multi-agent systems and their future, how they must change, or what is the next? You know, if you look at it, we started with computing with tubes, vacuum tubes, zeros and ones. Then we started to have machine language. Then we had our third object orientation, normal, traditional, conventional programming. Then object orientation. Then agents. So what's next? That's now what is there anybody who would like to make any suggestions?
So yesterday I sat in one of the sessions with a, what is it called, the physical network, I think the cyber-physical network. And from my point of view, as a computer scientist, I saw a lot of overlapping between multi-agent systems and these cyber-physical networks. And maybe the next step is maybe like a twin configuration where devices have the representation or the physical representation of an agent in the background. I don't know, that's maybe the next evolution of the multi-agent system. So I saw a lot of overlapping or potential methodology.
I have just reflection, thought, yes. About agent and multi-agent, it's a paradigm which 20 years, 30 years, you know. And the problem I find with the main problem I find with agent and all the model proposed in the generalization. I work on modeling and simulation of complex systems, but I can propose a model only for a property, a problem of a complex system, not to consider all the complex system. I think it's really a problem. BDI is a paradigm proposed for agent human-like, but it can be used in all the problems.
Yeah.
I know when I want to propose a solution for uncertainty, I use fuzzy logic. So I propose fuzzy agents, and fuzzy agent not only for agent who reason with fuzzy logic, but fuzzy agents which are fuzzy behavior, which interpret in interaction. Is this interaction interest me with a weight and me, an agent, and agent have a behavior in function of the interest of this interaction. For example, quantum agent is interesting for the concept of superposition states, when always in uncertainty. I don't know, I hesitate to 1, 0, 1, 0. Why not superposition state? And why not entanglement of these two states, and so on. I want just to say agent is not mature for general concept.
Yeah, I understand what you're trying to say. That's it?
I thought it is interesting the two Hellenic agent papers. You both needed some sort of analog for like uncertainty. You know, you got the sort of partial set inhibition of fuzzy logic, and you took the sort of measurement uncertainty from quantum mechanics. But both of the approaches had the sort of hierarchical structure that Hollands have, and then also the sort of blurriness that either fuzzy logic or quantum superposition gives you. So it's interesting that both of those approaches needed those things. That's recursive structure as well as that sort of blurriness.
Okay. Yes, there's no.
I was confused. Why the superposition quantum computer basically is trying to parallelize. You can highly parallelize, so you compare at the same time. So then how that will connect to the agent, you know, trying to understand the reason.
So this research doesn't try to implement agents on a quantum computer, on a physical quantum computer, but rather to ask a research question of how can we try and implement the principle of a quantum superposition into the design and the execution of a multi-agent system on a conventional computer architecture. So that might be another research question to ask on actual quantum computing architecture, but for this, it was more about the principle, the principle that quantum superposition exhibits, and how can we on an abstract level incorporate that into the design of multi-agent systems.
Two of the 5 papers used this the notion of Hellenic agents. If I remember correctly, there was a very famous physicist called David Bohm. He was the one who introduced this notion of Volan, wherein his Holland basically means that something is part and whole both at once. And he proposed the architecture of the universe is Hollandic in the sense that you can derive the entire design of the universe from a grain of sand. So the design of the universe is not only distributed across the universe, but it is concentrated in each and every part of the universe. So even the smallest part, which naked eye can see as a grain of sand, the entire design of the universe can be extracted from that. It contains the whole, the part, even though it is a part, but it contains the whole. So that was the architecture he had proposed long back. He is no more, but his work was quite appreciated, and many philosophical school of thoughts agree with his architecture, Hollandic architecture of the universe. It's good that it is being used in solving our problems, daily problems.
Okay, well then it remains for us to thank everybody, to thank all the speakers, to thank my co-chair and the audience. Thank you very much.